We can stop HIV, Iowa.
And it all starts with health equity.
Health equity means that everyone has a fair and just opportunity to be healthy.
To achieve this, we need to remove obstacles to good health.
Poverty and discrimination support an environment in which HIV thrives.
We must work together so that all Iowans have access to the resources they need to prevent, diagnose, and to treat HIV.
Visit StopHIVIowa.org.
Hi there, thanks for joining us. This is Space Nuts with Andrew Dunkley and Professor Fred Watson, and it's good to have your company. This week, Fred and I will be talking about the latest image from the James Webb Space Telescope, and we'll chat about some of those other images that surfaced last week, which has got everybody quite excited, and rightly so. We'll also be looking at a new deal that seems to have been struck between the United States and Russia in regard to astronauts and cosmonauts working together on the International Space Station. Given everything that's happening in the world, it's refreshing to see that something positive is happening. And the Mars crater that spat a rock at us, has been identified. We'll talk about that. And we'll be hearing from Mark in Quebec, who has a what-if question for us. I love those. And Rusty wants to ask us a question about quasars. That's all to come on this edition of Space Nuts.
15 seconds. Guidance is internal. 10, 9... Ignition sequence start.
Space Nuts.
5, 4, 3, 2. 1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
And joining us, as always, is the good professor himself, Professor Fred Watson, astronomer at large. Hello, Fred.
Hi, Andrew. How are you doing?
I am quite well. Had a lovely weekend. Went down to a place called Bathurst in the gold fields. The first place in the colony that was established outside of Sydney, I think, was Bathurst, wasn't it?
Yes, I think that's right.
Yes. They had their winter festival on, so we went down there and froze and ate ice cream and took the grandchildren down for a little bit of fun, and they had a good time.
Very good.
Yes, it's a cold part of the world, the tablelands.
Yeah,
it
is.
Don't venture there in winter very often if I can avoid it. What about you? What's going on in your world?
Well, I was in a place called Canberra the weekend.
Oh, that's even colder.
Yeah.
And I'm only talking about the people in Parliament.
Oh, I can't comment on that since I work for them. So, no, I was down probably worth a mention. Questacon is the National Science Centre down in Canberra, which I have a lot to do with. And its long-term director, Professor Graham Durant, who's a very able director and science communicator, has retired. So I was down for his retirement party, as it was. It was a valedictory address that was well worth going to. And in fact, it was some fairly important people there, including the Governor-General. He and his wife were at the event. So it was, yes. And, a former chief scientist and lots of other people, as well as an astronomer at large. But that was Friday night, so on Saturday, Marnie and I had a bit of a stroll around the lake. I took my scooter down because electric scooters are okay in Canberra, not in New South Wales, but they're good.
Oh,
But
yeah.
very pleasant.
And yeah, they do drive them around in Sydney a lot, and I saw a lot of them in Melbourne earlier this year when I was there. So, yes, they're very controversial too, those things, I must say.
Good fun, though.
Oh, absolutely. Absolutely. Now, let's talk about James Webb, the James Webb Space Telescope, which last week NASA released the first images, and we saw that just amazing image first up, which was a tiny sliver of the universe, but certainly one that was a spectacular image to release first time. But they've released a bunch more, and you can see them all on the NASA website. And now they've released another one of Jupiter, and that is mind-blowingly amazing. That one.
It is. It's really interesting because so the sequence of events was that the president sort of usurped the first release, so that that was done a day earlier than all the others, and that, as you said, was the one we talked about last week, which was that deep image, the Webb first deep field, I think is what it's been called, showing very distant galaxies, some of which were more than 13 billion light years away. Quite extraordinary stuff. And then the other tranche, there were 4 more that were released on Thursday last week, including including more galaxies, a group of galaxies which have been, I think they're regarded very fondly by astronomers and have been known for many years. It's called Stefans Quintet, and it's 5 galaxies, of which some are actually interacting. But what is staggering about I think they're about 200 million light years away, if I remember rightly. They're not in the distant universe, they're relatively nearby. But what staggered me about that image is that you can actually see individual stars in some of these galaxies. So the telescope is sufficiently powerful and has enough resolution that it is actually depicting these individual stars within that object, which is really quite astonishing.
It looks like a jellyfish.
Yeah, one of them does, that's right. But the spotted jellyfish with all the stars in it. And then 2 images of very famous objects representing opposite ends of a star's life. There's a lovely planetary nebula, sometimes called the Southern Ring Nebula, which is the shell of gas and dust that's been emitted by a star when it gets to the end of its life. In fact, a sunlight star. So this is something our sun will do in 3 or 4 billion years' time, maybe a little bit longer than that. It will form a shell around it, and it will be known as, to anybody observing it from the outside who speaks English, it'll be known as a planetary nebula, because that's the name that William Herschel gave to these things back in the 1800s. Because they looked a bit like planets, nothing to do with planets, but that's what they look like.
They look kind of opal-like.
Yes, they do. Yeah, I was noticed that as well, and that's to some extent the colours in them, which of course the Webb puts in because it's sensitive to different wavelengths of infrared radiation. And then at the end of a star's life, the IRINA Nebula, a stunning image of the edge of the dust shell, which is formed by hot young stars within a cloud of dust, blasting out ultraviolet radiation, which is piling up the dusty material to give you this edge, which looks like, well, cliffs or mountains, depending on which way you look at it. But it is an absolutely staggering image.
It is really amazing. And people do describe it as a mountain range. And as soon as you look at it, you go, oh, looks like a mountain range, and then at night being photographed.
Yeah, because it's got stars in it.
Yeah, but then you start realising, the stars are all over it, and got to read the caption to get the gist of the image
of what's going on. Yeah, so it is. It's material. There's this cavity that's been carved out by the radiation of these young stars, and what you're seeing is the edge of that cavity. It's a stunningly beautiful image. Actually,
it is, isn't it? And I'm pretty sure on the left-hand side that's Mount Rushmore, and that looks like George Washington.
He's probably there too, yeah. And then the final one that was issued last week was actually not an image, it was a spectrum. And good on James Webb for doing that, because what teaches us more about the universe than anything else is the spectrum of objects. The rainbow colours as the light is broken up, which extends, of course, into the infrared wavelength. We just don't see those colours, but those colours are there. And so this spectrum was of a distant exoplanet. If I remember rightly, it's WASP. I can't remember. It's 97b or 96b. 96b, yeah. WASP 96b, a hot Jupiter orbiting very close to its parent star. But what the spectrum shows quite definitively is that it has water vapour in its atmosphere. So it's now being described as a steamy hot Jupiter. And talking of Jupiter, the one thing...
Yes, indeed.
The one thing that...
Nice segue, Fred.
Oh, not bad, eh? Once in a while I can do those, but not very often.
It's only taken him 6 years.
6 years, yes, that's right. I think I might have commented, I can't remember who it was too, it might have been you. I was surprised that there weren't any solar system objects in that first tranche of data.
No, you didn't say that to me, but I am surprised too.
Yeah. And, they've made up for it because we've now got this extraordinary image of Jupiter, which shows... it's a slightly anemic-looking image, but and the great red spot is kind of overexposed, kind of white in colour, presumably because it's so bright in that frequency. I think it was 2.2 microns, if I remember rightly, that this wavelength this was taken, which is the mid-infrared. Sorry, it's the middle band of the near-infrared is where it is. So not far beyond the red end of the spectrum. But what I noticed was just how much detail there is in the cloud belts. And it's when you see those swirling vortices that are shown up in the cloud belts, it's very reminiscent of what we've seen from the Juno spacecraft, which is, in orbit right next door to Jupiter. So I think we're going to see some very dramatic stuff coming from the James Webb telescope in the solar system. And the image I'm looking at too actually captures, I think it's Europa.
It is Europa.
Which has got a black dot in it, which I think has been put on just to occult the disk of Europa, stop it from sending too much infrared radiation back. And you can also see Europa's shadow on the planet's cloud belts as well. Very,
right
very
near
nice.
Right near the red spot.
Right near
actually.
the red spot. That's right.
That's it. Yeah.
Yeah. These are fantastic tasters to what the Webb is going to be able to achieve, and all credit to the whole team for getting it all together.
Absolutely. Early days yet, but what a great start
Yes,
to
exactly.
this longitudinal project.
Indeed.
So, yes, if you want to see those images, they're on the NASA website, but phys.org also has them. So pop along and take a peek. Now, Fred, let's move on to this next story. And I find this fascinating given the current state of affairs in the world, but it looks like American astronauts and Russian cosmonauts will continue to work together on the International Space Station. But we also have another quite incredible piece of information to pass on regarding Roscosmos, and this is sort of hot off the press, isn't it?
Yes, I think so. Well, let's talk about that first, because we've mentioned this gentleman before. He's featured quite a bit on our podcast. Dimitri Rotin is his name. I hope I'm pronouncing that correctly. Who's been the very pro-Putin head of Roscosmos. He has been moved on, but it sounds from what we're reading that it's not a demotion. We're not getting the idea that President Putin is unhappy with Dimitri Rotin, and that comes from a Kremlin spokesman who's basically said that. But there is a rumour in the media suggesting that he might be promoted to be put in charge of the occupied territories in Ukraine, which I suppose fits in with his strong pro-Putin stance. But he's said a lot of things that are not really all that pleasant about the International Space Station. One of his tweets said, "If you block cooperation with us, who will save the ISS from uncontrolled deorbiting and falling on US or European territory?" Which is a bit, sort of in your face.
Yes.
So anyway, we will see what happens. And I'm not sure if we have a name yet. I'm just checking up for
as to who will replace him.
Successor, that's right, because, that's is a key role. Okay, yes, he's being replaced by a gentleman by the name of Yuri Borisoff. And I don't know anything about Yuri Borisoff, but hopefully we will find out what his stance will be on these sorts of things. He's hardly likely to be, he's highly unlikely to be anything other than a Putin sympathizer. But, maybe his stance on the space and space cooperation might be a bit different, because that's the crucial thing. The International Space Station absolutely depends on cooperation between the five agencies that operate it, which are ESA, Roscosmos, NASA, and is it JAXA, I think, the Japanese Space Agency?
The Japanese Space
and
Agency.
the Canadian Space Agency, yeah. So a major cooperation. And that's what the other part of this story is about, that NASA and Roscosmos have actually signed a new agreement, which has been in the offing for a long time, to integrate their flights to the International Space Station. So basically, Russian cosmonauts fly on Crew Dragon or any other US-made spacecraft that are introduced, and American astronauts fly on the Russian Soyuz spacecraft. So it's a deal that's been done in the face of probably certainly a pretty difficult time. We do know that the cosmonauts and the astronauts themselves have formed very strong relationships, and I think they're working well together on all fronts. Yeah, but
I don't suppose you have much choice.
You've got no
but
choice.
Put the politics aside.
Exactly.
And let's face it, the people up there that are doing all that work on the International Space Station probably have very little to do with what's going on in Ukraine. In fact, I think the vast majority of Russian people are probably in that boat.
I think you're right. I think that's right. Sadly, yes.
Yes, indeed. But maybe it's not a coincidence that these two announcements came at the same time, because one will soften the blow involving the other, I imagine.
Yeah, maybe. Yes, that's right. I mean, yes. Well, certainly good news that that we've got this cooperation, this deal signed between the two space agencies. And maybe it's good news that Dr. Rogotin is no longer running. Who
Maybe,
knows?
yeah,
We just don't know. We simply don't know.
He's been a bit out there, a bit outrageous, and a bit out of his depths sometimes, I would think. But,
maybe that's right.
Yeah, so he's got a new gig. If I remember rightly, a lot of the Russian launches come out of Ukraine, don't they?
No, it's
Do they have a
Kazakhstan.
space?
Kazakhstan.
Yes.
Yeah,
I knew it was
Baikonur.
somewhere around there. They're launching enough in Ukraine anyway at the moment.
Well, that's right. It's a different kind of rocket, though, isn't it? Yeah.
Yeah, indeed. But we'll watch with interest. But it's good to see that relationship seems to be fairly strong, at least in terms of the International Space Station and the deals there. Mm-hmm. This is Space Nuts with Andrew Dunkley and Professor Fred Watson. Let's take a break from the show to talk about our sponsor, NordVPN. Now, NordVPN provides you with online security. You can cover up to 6 devices with the one account, and that includes your smart TV, your router, your smartphone, your tablet, your laptop, or your desktop computer. You might have a combination of those things. This is a great plan. And Nord is the best in the business. They've been doing this for a very long time. They also have the fastest servers, and sometimes you can get faster speeds by connecting to NordVPN than you get when you connect to your internet service provider. Now, there is a special deal for you as a Space Nuts listener, which I'll get to in a moment, but there are different plans. You can go a 2-year plan, a 1-year plan, or a monthly plan. Within those, there are different levels of service. Now, let's just take a look at the 2-year plan, because it's obviously going to be the least expensive. And if you go for the complete package, you get secure high-speed VPN, malware protection, tracker and ad blocker protection, cross-platform password management, data breach scanning, and 1 terabyte of encrypted cloud storage. So that's the ants pants as far as a combination deal is concerned. And you can get it at a very, very low price, including 1 month free. And don't forget, there's a 30-day money-back guarantee with NordVPN. So the URL you need to go to is nordvpn.com/spacenuts. That's nordvpn.com/spacenuts. Click on the grab the deal button and go from there and choose your options. But I would certainly suggest the complete package over 2 years gives you the best bang for your buck. But whatever you choose, you're going to get a great deal from NordVPN. That's nordvpn.com/spacenuts, and use the code SpaceNuts when you sign up for NordVPN, our wonderful sponsors. Now, back to the show.
Roger, you're loud and clear here also.
Space Nuts.
Back to the red planet, Fred. Mars. It's in the news a heck of a lot, not as much as James Webb has been of late, but there's a lot of exciting things happening on Mars. This is completely different. This has nothing to do with sailplanes or helicopters or rovers. This has got everything to do with a hole in the ground, or a crater that sent out a significant piece of rock. So tell us what's going on here.
Yeah, so Martian meteorite, I think the number of known meteorites from Mars is now, I think it's in the hundreds. I remember writing about it more than a decade ago, and it was about 30, but I think it's well above that, might even be 200 or so. How do we know they come from Mars? Because they contain little pockets of air in them which match Mars's atmosphere exactly. And so one of them in particular, which has a technical name, but is usually called the Black Beauty. It's one that was found actually back in 2011 in northern Africa, and you know that region is one of the places where meteorites are commonly found. There in Antarctica, because you've got sandy deserts in northern Africa, you've got snowy deserts in Antarctica, and black meteorites show up pretty well in both those environments.
Yeah, I've just found a photo of it. It's a stunning
It's
rock.
lovely, isn't it? And I've found its technical name, which is NWA 7034, but it's usually called Black Beauty because it is such a beautiful piece of rock. And it's unusual because rather than being a chunk of basalt or a chunk of granite or whatever, it is actually what's called breccia. It's a rock that's made of an amalgam of many other different kinds of rock. So it's not just, a single rock, a type of rock. It's lots of other stuff, all bits and pieces of other rocks, all kind of bonded together, cemented together. And I think that's been one of the clues that's allowed scientists, in fact, based at Curtin University here in Australia, and I think they're using the Pawsey supercomputer. Yes, the Pawsey Supercomputing Research Centre, which is partly operated by Curtin, and actually plays a big part in data reduction for the Square Kilometre Array and its precursor telescopes here in Australia. Anyway, these scientists, what they've done is they've said, okay, here's a chunk of rock which contains a bit of a mix of other stuff in it. Can we find where it came from? Where the impact took place? Because that's how these Martian meteorites leave Mars. They're the result of an impact on Mars's surface. And I think in this case, it was between 4 and 10 million years ago. It's been dated at that sort of level. It's only been on Earth for 11 years, since 2011. So it probably wandered in space for many millions of years, having been dislodged by an impact on Mars's surface earlier on. So what these people at Curtin have done is looked at the sort of global images that we've got from various spacecraft which have mapped the whole of Mars. And the first one is to look at the distribution of craters, and I think they've mapped, is it 90 million? I can't remember. I don't have it in front of me.
Wow.
90 million craters, a huge number of craters. I should check that looking back at a different article, which I don't have in front of me at the moment. But anyway, they've basically identified lots and lots of craters. Then they've looked at the Mars Global Surveyor data, a NASA spacecraft, to get the topography, the sort of height of the land, how thick the crust is. That comes from actually all of Mars's orbiting spacecraft in Mars, or former orbiting spacecraft. Mars Reconnaissance Orbiter, still going strong. Mars Global Surveyor, Mars Odyssey, I think those two going strong anymore. I'm not sure about that. But they've got crustal thickness data, and that comes from gravity measurements, basically. Then they've looked at the magnetism, looking for magnetic anomalies on Mars, and that comes from the MAVEN spacecraft, or MARVEN, which is partly there to sense Mars's atmosphere, but also looks for magnetism. And then finally, from Mars Odyssey, they've maps of the thorium and potassium abundance, in other words, some chemical abundances on Mars. And so what they've done is all these different sort of maps of Mars have been combined together in an AI program, where what they've done is sifted through all this, the artificial intelligence system, and looked for craters that would have been formed in a way that would have generated the Black Beauty with its brecciated structure. And sure enough, they found one, which is fantastic, which I think they're giving a name, actually. I think it's going to get an Australian name. Karatha Crater, that's right.
Karatha Crater.
Yeah. So it is a fantastic story. Yes, what it does is demonstrates, and I've just confirmed, yes, it is 90 million craters that they mapped. What it does is demonstrate the power of supercomputers in terms of doing this kind of science. And yeah, I think it's a fabulous outcome, and all credit to the team at Curtin University.
I think it's remarkable that you can find a rock that's like that big as your fist or something like that, and have the technology to go, okay, we found that rock there, but it came from there, all those millions and millions of kilometres away.
Yes, and millions of years ago.
Years.
It's remarkable.
It prompts a question, though. We are finding rocks all over the place from Mars that have obviously been ejected due to a high impact event on the Martian surface and sent out into space, float around for a couple of billion years, and then get caught in our gravity and sucked into our atmosphere and end up wherever they end up, and we find them. Do we know of any other rocks from any other objects? I assume the moon, there'd be a few, but what about Venus? What about Mercury? Would we have any of those?
That's a great
on our
question.
planet?
There are certainly many lunar meteorites. I think that they outnumber the Martian ones. I don't know the answer to that. I think it is probably no, because you don't really hear about them.
Because they're inside the...
It might be, yes, just because they're, I guess, as they wander around in space, they're more likely to be pulled in towards the sun rather than, drifting.
So is it possible then that pieces of the Earth are on Venus and Mercury?
That's a lovely thought, yes. I guess you're probably right, Andrew. That's some great lateral thinking there.
Yeah, well, I mean, there's a lot of Mars on Earth. So
there is.
I wonder if there's probably pieces of Mars on
the
Venus.
Yeah, there might well be. I mean, Venus is, it's hard to imagine us ever going looking for Earth meteorites on Venus, just because it's doing anything on Venus is such a high risk and difficult venture. Yeah.
Oh, yeah, it's just such a hostile environment. It's I saw someone the other day who shall remain nameless, who flies for British Airways and is a very big follower of the show, whinging about 21 degrees in her greenhouse in England the other day. England is Venus-like at the moment, with temperatures up around 40 during the day.
Pushing 40, that's right, yeah.
Yeah, they know what it's like.
Yeah, they do, yeah.
They don't have to come here now to understand what it's like here sometimes.
That's correct.
They don't have to worry about that. Hi, Hannah. But yes, it is fascinating that we swap all this stuff. I mean, when I was growing up, no one ever thought about that kind of thing. Right. And we just knew rocks hit us, and we just
didn't know much about them.
I'm sure. But now we can identify the exact spot that they've come from in some respects.
Certainly as far as Mars meteorites are concerned, it's only been since 1976 that we could have recognised them, because that's when the Martian atmosphere was first measured by the Viking spacecraft. They actually analysed the atmosphere of Mars, and it's since then that we've been able to say, oh, this has got pockets of Mars air in it, so we know it's from Mars. Of course, before that you couldn't have done.
Yeah, absolutely, yes. But it's worth looking into that story. And again, phys.org is where you'll find it if you want to read up on it and have a look at that Black Beauty meteorite that came from Mars. It is an absolute ripper. And while I'm talking about rocks, one of the things we did last weekend in Bathurst, Fred, is we visited the Australian Fossil and Mineral Museum, which hosts the Somerville Collection. Warren Somerville has been collecting amazing minerals for his entire life and donated much of his collection to the museum in Bathurst. And you go through there and you can just learn so much about all the minerals that exist on Earth and how we use them. I mean, they have little cabinets with all these different types of, let's think of calcite, for example. And on the bottom, it'll show you what we use calcite for and all sorts of other things. Yeah. It's fascinating. And then right out the back, the go-to object is the full-scale, 100% intact, fossilized skeleton of a T-Rex.
Oh,
it is. Oh, yeah.
Wow.
It is amazing.
It is, yeah.
My grandson was so enthralled by that. It scared him, actually, because it is humongous.
Yeah. They weren't small.
Yeah. And there's a smaller one next to it now. I think it's an Albertosaurus from Canada. Mm-hmm. That's what it's called, an Albertosaurus, but it's a big meat eater as well. So, yeah, if you ever get to Bathurst, you've got to do the museum, see the Australian Fossil Museum, because it's fantastic. That's by the by, but we were talking about rocks, so I thought I'd throw it in there.
Oh, it's a good one.
Yeah. This is Space Nuts with Andrew Dunkley and Fred Watson.
3, 2, 1.
Space Nuts.
Now it's time to let you quiz us, or more specifically, Fred, with questions from the audience for another edition of Space Nuts. And I did mention Albertosaurus in the previous segment, and just so happens that our first question comes from Canada.
Salut, Fred and Andrew. I'm Mark from Sherbrooke in Quebec. Now here's a question. I really cannot get around in my mind. And Andrew, you like what if questions, so here's one. Now, what would happen if a black hole that has the exact same mass as the Earth would touch our planet? Well, first, what would we see, and for how long? And what would happen to the black hole? And what would happen if a black hole that would be just slightly less massive than the Earth would touch our planet? So thank you for listening to my question, and thanks again for this absolutely amazing show, guys. So sending lots of love from Quebec. Bye-bye, merci.
Oh, lovely accent. Thank you, Mark, and thanks for the endorsement. That's terrific. Yeah, if a black hole touched Earth, I don't think we'd be around to see that, to be honest, but we might see something in the time leading up to the event.
We might.
Would that be fair to say? Right. We might. We'd certainly see ourselves stretch out into long strings of spaghetti.
That's right. That's the bottom line there, Andrew. It's what happens when you've got black holes of equal mass is they spiral around one another, kind of their orbits around their common centre of gravity getting smaller and smaller until they finally coalesce and form a black hole, which is not quite the sum of their masses, because some of that mass is radiated away, is lost and radiated away as gravitational waves. And I think something similar to that would happen. So if a black hole wandered near the Earth, started approaching, then it would become gravitationally the main thing pulling the Earth, and the two, no doubt, they would continue orbiting the Sun, but the two would orbit one another in ever decreasing circles. And as the black hole got nearer and nearer, the Earth, its structure would not be able to withstand the gravitational gradient, which is the critical thing, by how much the gravity is changing. And that's what gives rise to tides on the Earth. So it happens with the Moon. The Moon pulls one side more than the other, and we get spaghettification of the ocean, if I can put it that way. But with a black hole, it's much more acute. And so, yes, the rocks start getting pulled apart and would not be a good outcome. Yeah. Regarding what we'd see, is interesting because if I remember rightly, the event horizon diameter of an Earth mass black hole, I think the figure is 18 millimeters. So you're talking about a black blob 18 millimeters in diameter. But of course, it might be surrounded by an accretion disk. Well, it would be, because the bits of the Earth would make an accretion disk around it. But yeah, it would be curtains for the Earth, I think, is the answer to that.
Are there black holes that small?
We don't know. The Hawking theory was that Earth mass black holes were created in the Big Bang, and in fact, the suggestion is that various sizes of black holes might have been created in the Big Bang. But they're called what are called primordial black holes, and it's still a fairly active theory that there are many sort of planetary mass, you might call it, black holes which are primordial, which originated in the Big Bang, lurking around in the universe. But we haven't really got very much evidence of them yet. So it's still a theory.
Well, if one ever turned up,
we would
evidence of it pretty quickly, I imagine.
Be fairly compelling and final evidence, wouldn't it?
Yeah. There's this book that I'm aware of that has micro black holes in it, which I thought was a great idea at the time. So that was in Parallax.
It's your Parallax book,
that sort of that sort of formed the basis of the storyline. Micro black holes.
I seem to remember that. Yes.
Yeah. So I thought that was just dumb, but it seems like there might be something to it. Yeah. So there you are, Mark. It would not be pretty. It might be pretty to look at, but it wouldn't be pretty for Earth or its inhabitants or anything else for that matter. We'd just become a big pile of junk spinning around
We'd be then in the black hole, which is and
then in. Yes. All right. Thanks, Mark. Great to hear from you. Let's go to Western Australia, and Rusty's got a really good question.
Hey, Fred and Andrew. It's Rusty in Donnybrook. In the last show, you talked about quasars, and I'm wondering, Are quasars bright in all directions, or are they only bright in the directions of the poles of the black hole? And if that's true, there would have to be many more quasars out there than we can actually see. What are the chances there would be some inside a couple of billion light years that we just can't see? Thanks for what could possibly be the best podcast in the universe. Cheers.
Thanks, Rusty. And for those listening and watching live, perhaps, there's a distinct theme with question selection here. You've got to say nice things about it. Nice things about us. Otherwise, you don't get on. No, that's not true.
Yeah, well, yes.
No, I'm just kidding around. Just kidding around. But thanks, Rusty.
The nice thing is that
Rusty's one of our regulars.
Listeners tend to say nice things about us, which is very nice.
Yeah,
we listen to the ones who don't as well.
Yeah, we do. And quite often we answer them, and we're okay with constructive criticism. That's fine. Now, quasars. I suppose, we should just review what a quasar is for those who may have not been au fait with them, and then we can build on that.
That's right. They were a mystery for many decades. So it was in the 60s that we first started observing these things. And in fact, the first ones that were observed in radio waves. And nomenclature issue here, because I think they were the ones that were called quasars as an abbreviation from QSO, which is a quasi-stellar object, and that really gives you the origin of the name. Looks like a star because it's a pinpoint of light or radio waves, but it's not. It's not a star. It's only a quasi-star. And then they were discovered in visible light, and it was only when you could see the visible light coming from these things that you could recognize that they were a very long way off, because they were highly redshifted. The light of the, from the individual spectrum elements, which was mostly hydrogen, that was redshifted by quite high levels. And that tells you that you're looking at something a long way away. So, so that was the sort of observational side. Back in the 60s, we knew about quasars, but it was only probably in the 80s or even 90s that they were associated with black holes, because the problem with a quasar was that they seemed to be delivering huge amounts of energy, but they had dimensions that were very small. They were solar system sized. And you get that observation very quickly if you can see them varying in intensity, because if they vary over a short enough timescale, you can tell that it can't be bigger than, the light travel time across that distance, across a distance. So that ties them down as being very compact. And that the only thing that could give rise to that amount of energy coming from something that compact was the accretion disk around a black hole, the material swirling around it and being excited to extremely high energies and delivering that energy as radiation. So that's what we are. They are in the centers of galaxies. And that was only realized fairly late in the day, when people got good enough images to realize that these quasars had galaxies around them. They're usually called the host galaxy. And now we associate the quasars with activity around the supermassive black hole at the center of those galaxies. And now, Rusty's question is on the money, because he mentioned whether there might be quasars within, say, 2 billion light years. And it's only around that distance that you start to see them, which is telling you that in today's universe, they are, if not extinct, they're very rare. There is one, I think, that's about 700 million light years away. I think it's a bit of a rarity, though. So generally speaking, you don't find quasars in today's universe, because they seem to have, that basically they've run out of the fuel that was supercharging them to be energetic. Now, the nub of Rusty's question is, do you only see them when you're looking down the jets of material that basically emitted at right angles to the accretion disk? And that's what we used to think, that we only saw them, when they were spotlighting the Earth. Because the Earth happened to be in the beam of one of these things. But I think now the consensus is the accretion disk itself is so bright because it delivers so much energy that you can actually, that's what you can see. And so they emit their light in all directions, which is actually what Rusty's question was.
Okay. So we could have just said yes.
Yeah. I thought I'd, say yes, slightly embellished with, a bit of background, what a quasar is, raking back through my memory.
Yeah. Well, I did ask you to do that.
Yeah.
No. Yeah.
No, that's all right. Anyway, it's yes.
All right.
Thank you, Rusty. It's yes.
It's yes, Rusty. Very astute as always, though, is Rusty.
Good question.
Thanks, Rusty. Hope all is well in Donnybrook, WA. That brings us to the end, Fred, but I do want to remind people if they want to send us questions, please do so via our website, spacenutspodcast.com or spacenuts.io. And there's a couple of ways you can do it. The AMA tab is where you can send us text or audio questions, or the little tab on the right-hand side of the screen that says send us your audio question. You can press that. As long as you've got a device with a microphone in it, you can record a question. Don't forget to tell us who you are. And while you're visiting the website, check out the shop, because there's lots of stuff in the shop. Fred's latest book is in there as well. Don't forget social media. We're on Twitter. We're on Instagram. We're on that other thing, TikTok. And we're on Facebook as an official page, but we also have the user-generated page, the Space Nuts podcast group. So whatever takes your fancy, don't forget to visit. And send us your reviews. Well, don't send them to us. Send them to your podcast distributor. If you're listening on iTunes, you can do a review. If you're listening on Spotify, you can do a review. Google Podcasts, wherever you listen to us, you can do a review. And more reviews, more people get the message that we're out there. That's more listeners. That's more people who are hearing what Fred has to say about what's happening in astronomy and space science, basically. But yes, that is the end. Thank you, Fred, for your company this week. As always, much appreciated.
I appreciate it too, the fact that you changed the schedule around to suit my comings and goings. I appreciate that very much. And thank you, Andrew. Always great to chat.
It's a big advantage being retired when last-minute changes happen. Yeah, no problem. I wasn't doing anything. Yeah, it's all good. Thanks, Fred. See you soon. Fred Watson, astronomer at large, part of the team here at Space Nuts, and thanks to Hugh in the studio who had to dash home last minute to put this all together and get us out there live for the recording session. He'll have to run back to the track and see if his horses won later. And from me, Andrew Dunkley, thanks for your company. As always, looking forward to catching up with you again on the very next episode of Space Nuts. Bye-bye.
Space Nuts. You've been listening to the Space Nuts podcast.
Available at Apple Podcasts, Google Podcasts, Spotify, iHeartRadio, or your favorite podcast player. You can also stream on demand at Bytes.com.
This has been another quality podcast production from Bytes.com.